Welcome to this video lecture on the subject Optical and Microwave Engineering. In this lecture, we are going to discuss about propagation of light, optical fiber characteristics. So let's see the introduction. So communication is the transfer of information from one point to another point. So communication system is achieved by modulating the information onto an electromagnetic wave which acts as a carrier for the information signal. So the electromagnetic wave carrier is selected from following range of frequencies: radio frequencies, microwave and millimeter wave frequencies, and optical range of frequencies. So the limitation is information carrying capability at the radio and microwave frequencies. So the information carrying capability is proportional to the bandwidth of the channel. So radio communication system where information modulates a high frequency carrier. So the information carrying capability is increased. So bandwidth of the channel is increased. Available spectrum space is decreased. So microwave signal used as a high frequency carrier and the cost of equipment is high. So when coming to the fiber optic communication, so light is used as the transmission medium. So the electromagnetic wave carrier optical range of frequencies from 1.76 picohertz to 3.75 picohertz. So communication at optical wavelength 800 nanometer to 1700 nanometer. So it offers an increase in bandwidth by a factor of 10 power 4. So general communication system consists of information source, transmitter or modulator, transmission medium and receiver and destination. Optical fiber communication system consists of an information source, electrical transmit, optical source and then optical fiber cable and optical detector and electrical receiver and then destination. So this is a general fiber optic communication link which consists of a transmitter and receiver regenerator. So in the initially electrical input signal is given to the optical transmitter which consists of a driver circuit and then the light source. So here the electrical input signal is converted into light signal and it is connected to the optical fiber through connectors. So the optical splicer is used to connect the fiber optic cables. So the live signal is transmitted through this optical fiber. Then it is given to an optical coupler or beam splitter to split the signals. Then it is given to regenerator for the purpose of amplification. So it consists of an optical receiver and optical transmitter where the signal is again converted into optical signal and transmitted, and optical amplifier is used before the receiver circuit. Receiver consists of a photodetector. So to convert the optical signal to electrical signal, and it is amplified and original signal is obtained. So output is the electrical signal. So this is how then optical fiber communication is working. So digital fiber optic link consists of a digital information source and encoder and laser driver circuit, and laser is the source and then fiber optic cable and avalanche photodiode to detect the signal, amplifier and equalizer, decoder, and then digital output signal is obtained. There are fiber optic modes. Optical fiber consists of a dielectric waveguide. It operates at optical frequency which is cylindrical in form. The fiber is cylindrical in form. So modes of the waveguide, it is the propagation of light along a waveguide can be described in terms of set of electromagnetic waves. So these guided modes are referred to as bound or trapped modes of the waveguide. And fiber structure, so it has a core and cladding. Core is the single solid dielectric cylinder which has the refractive index of n1, and cladding is where it is surrounded by core is surrounded by cladding and refractive index of n2 which is less than n1. So this cladding reduces the scattering loss. It provides mechanical strength to the core and protect the core from the absorbing surface contaminants. And apart from this, we have buffer coating. It is an elastic absorption resistant material. You add further strength to the fiber. Features of optical fiber communication, which is ultra high bandwidth, small size and weight, electrical isolation, so immunity to interference and crosstalk, signal security and low transmission loss, ruggedness and flexibility, system reliability and ease of maintenance, potential low cost and point-to-point communication. So these are the important features of optical fiber. Applications are long distance communication backbones, inter-exchange junctions, video transmission, broadband services, computer data communication, military application and non-communication applications like fiber optic sensors. There are types of fibers and variation in material composition of the core gives two types of fiber, step index fiber and graded index fiber. Where step index fibers, refractive index of the core is uniform throughout and undergoes abrupt change at the cladding boundary. Graded index fiber, where the refractive index of the core is made to vary as a function of radial distance from the center of the fiber. So based on the modes, two types of fibers are available, single mode fiber and multi-mode fiber. So this is the comparison between single mode and multi-mode fibers. In single mode fiber, core radius is small, whereas in multi-mode fibers, core radius is large. So single mode supports one mode of propagation, whereas multi-mode supports hundreds of modes. For the single mode, laser is used as the optical source, and for LED is for used as the multi-mode fiber. And launching of optical power into a fiber is difficult as the core radius is small in the single mode fibers, whereas in multi-mode fiber launching of power is easier as the core radius is large. Single mode supports larger bandwidth and multi-mode supports lesser bandwidth. So intermodal dispersion is absent in the single mode, whereas these fibers suffer from intermodal dispersion in multi-modes. Single mode fibers are used for long distance communication, whereas multi-mode fibers are used for short distance communication. So these are the various optical fiber configurations. The first one shows the single mode step index fiber, and where it supports only one mode of propagation. And next is the multi-mode step index fiber, where the core radius is around 50 to 200 micrometers, and in multi-mode graded index fiber, in which the core radius is 50 to 100 micrometer. So you can have an assessment. First question is, multi-mode step index fiber has a larger core diameter range of, the answer is 100 to 300 micrometer, because the multi-mode step index fiber has a core diameter range of 100 to 300 micrometer in order to facilitate efficient coupling to inherent light sources. Second question, single mode fibers allow single mode propagation. The cladding diameter must be at least which of the following? So the answer is 10 times the core diameter. Thank you for listening.